Everyone, this is Fariha Kobe Torsha and welcome to INDE 6332 Engineering Project Management Assignment 4. We are Group 3 Mission Control and I am the project manager for this assignment. Assignment 4 is on planning tools such as WBC, LRC and the Gantt chart for execution of the marine vessel construction project. Let's start with the key highlights of our project. Our selected vessel configuration is 36-foot aluminum hull with twin engine and a half cabin. In this assignment, we developed three essential planning tools: a work breakdown structure WBS to systematically plan the vessel's construction from the hull fabrication to shipment, and a linear responsibility chart LRC to clearly assign roles and responsibilities, and a Gantt chart scheduling in 20 weeks timeline from January to end of May 2025. Now let's discuss the work breakdown structure or WBS. This is a critical tool that helps us decompose the project into smaller, more manageable tasks. It is important because it helps the project planning by dividing complex deliverable into smaller actionable tasks. In the methodology, we followed a system-based WBS approach, meaning we categorize the project into major systems such as hull, propulsion, electric system, etc. Each major system was further broken down into subsystems, and finally we defined the work packages at the lowest level. For this project, we choose a system-based WBS approach because it mirrors how the vessel is actually built and the bill of materials, and it allows the different system to be worked simultaneously, ensuring a clear visibility, task management, and efficient execution. The vessel construction is divided into 9 major systems: the hull, anchor, crane, propulsion, freshwater, sanitation, electrical, navigation, and the lighting system. In total, we have 268 work packages covering all phases of planning, construction, final testing, and delivery. Let's take the hull system as an example. It consists of several subsystems such as hull, deck, rudder, etc. And all the activities under them can be fall into few categories such as specifying, ordering, receiving and inspecting, fabricating, assembling, installing, and finally testing. As we move forward, we will see the WBS for all the systems during the LRC discussion. Now that we have defined our work packages to WBS, the next step is to assign clear responsibilities using LRC. The LRC ensures the accountability by defining who is responsible for each task. We categorize the roles and the responsibilities into 4 levels. We have primary, secondary, approval, and review. This slide shows how we structure the responsibilities for the planning and the hull system using the LRC. All the work packages for a subsystem can be done into 6 activities as we discussed before: the specifying along with the compatibility and sizing, and then ordering or purchasing the components, and then receiving and inspecting or the individual testing, whichever is necessary. Finally, we have the fabrication, also the assembly. Then we install and the secure and installation check, and finally the system testing. By embedding the testing at multiple levels, we identify and address the issues before it can escalate. We assign each work packages to the suitable or the compatible department. In Homework 2, we have built our organization structure, such as a pure project structure. We have Aksh for manufacturing, Tolani for R&D, Gilbert for finance, Quill for legal, and Pelumi for management, and Torsha for marketing. The flow of the assignment goes like this. In the planning phase, R&D leads the LRC as they define the technical responsibilities, while manufacturing is in the supporting for the base alignment. Also, finance gets involved in the LRC because of the assignment responsibility often impacts the procurement, the resource allocation. Management also take part in the LRC for the review. For the construction of the vessel, the role of the manufacturing and R&D vary depending on the system or the subsystem, its complexity and the technical requirement. Generally, manufacturing leads the sizing, the specification to ensure the feasibility in the production, while R&D is involved in more technical systems, ensuring accuracy. The purchase is led by the finance, ensuring the budget control and the cost efficiency, with manufacturing as secondary. As hull and the deck materials are high-value components, management is also involved in the approval. Receiving and the inspection is handled by manufacturing, so does the the assembly and the fabrication because of their expertise. For the subsystem requiring high technical precision, such as electrical propulsion, R&D plays a significant role in specifying component, overseeing the installation, and conducting the critical testing. This ensures the system performance, compliance, and reliability before integration. For anchor and crane, we see the similar kind of assignment. Here for the crane, we involve the R&D in the load testing and the safety inspection because they ensure the structural integrity, weight distribution, and compliance with the safety regulation. In propulsion, R&D is involved in secondary for critical technical tests such as the engine dry land testing, exhaust noise reduction, etc. For sanitation, we see the similar kind of responsibility assignment to each department as we discussed before. In the electrical system, along with the manufacturing, we have high involvement of R&D in the specifying installation and testing. This is because the electrical components such as the generator, exhaust, cooling, battery requires technical precision and safety validation. For the freshwater system, we have the similar kind of work assignment based on the department. Since the navigation involves critical positioning and sensor integration, we see high involvement of the R&D along with manufacturing. For the lighting system, manufacturing leads the installation and integration while R&D supports in the specifying component. For the CAC trial, we ensure the vessel performance and safety with the R&D leading testing for speed, maneuverability, safety, and having manufacturing in support while management oversee the whole process. For vessel modification is handled by manufacturing with R&D in assisting, management in overseeing. In the final product delivery, marketing handles the documentation, finance approves, and ship delivered by management and the legal approval. And also finally, we terminate the contract by involving the legal, management, and finance, ensuring a smooth project closure. Now, let's focus on the Gantt chart. So Gantt chart is a visual scheduling tool that maps the task against time. It is important because it is visually maps the project timeline, track the task dependency, and ensure on-time completion of the project. The methodology is it starts with the we assign the start days and the work days for each work packages based on the WPS, and we also establish a task relationship to maintain a logical sequencing. For example, hull and the deck structure has to come first before we work on propulsion. We also have structured the timeline to allow the parallel work while ensuring the critical dependency. So first is the Gantt chart for planning and health system. So in the planning, we take 5 days, and it is week 1. And at the same time in week 1, we start procuring for the hull and the deck materials. And then in week 2 and 3 we received and the inspection is done. And week 4 and 5 is for fabricating, assembling, and the testing. And by 5 it is done. For the rudder and the mooring and the safety component installation, it starts from week 6 to 8 after the main hull and the deck are stable. An anchor system is installed by week 9 and the crane by week 10. For the propulsion, all the purchase and reception done by week 6 and 7, then assembly and testing start from week 13 after the crane is installed. For freshwater, installation begin at week 9 after the mooring safety component installed, and it ends by week 10. For the sanitation, we start from week 10 to 12, and then for the electrical system, as it is a crucial system for our vessel, it and other system also rely on it. So we start procuring early in week 2 to 5, and once the hull structure has been built, we start the installation and the testing. The generator and the battery system specifically are completed by week 10 and 11. The monitoring, the communication comes later in week 12, and it ends in week 16. For the navigation, it starts from week 9 to 12, and for the lighting, it's 11 to 12, as lighting depends on electrical part has been completed. Finally, we have the sea trial, vessel modification, and final product delivery. So for sea trial, we take about around 10 days where we do the speed testing, maneuverability testing, and then we have vessel modification, which is 7 days, and the final product delivery is takes 4 days. So all the trial starts from week 16 after all the construction has been done by 21 of the April. So from 22 of April we start the sea trial, and we finish by 20 of May, which is well within our target timeline. And in total, we take around 100 days to complete the whole project. So this 100 days is only the working days, not the weekends. And after by that, we are done here. Thank you very much.